Okay, welcome to homework 11 solution video. And this is the last one that I'll be posting, which is, it's a little sad, I think. A little sad for me, at least. But we get to do some fun stuff. We get to do integration. Oh, wow. Okay. All right, so let's evaluate and simplify the following. There's three parts. Definite integral from 1 to 2 of 3x to the fourth plus secant squared of pi over 6x dx. Okay. All right, so first, a lot of students were splitting this up into the integral from 1 to 2 of 3x to the fourth plus the integral from 1 to 2 of secant squared of pi over 6x. I don't know if that's the best way to do it. I think it's probably just easier to read it right off. But if you'd like to split it up, there's nothing wrong with that at all. But I'm just going to leave it as one and do each antiderivative by themselves and then evaluate on the interval. So what I mean by that is using our reverse power rule, 3x to the fourth becomes 3x to the fifth over 5. And then secant squared of pi over 6x becomes tangent of pi over 6x divided by pi over 6. And that whole thing is evaluated on the interval 1 to 2. Okay, so now I plug 2 into the whole thing, whereas if I'd split it up, I would plug 2 into just this first part, then the second part. Doesn't matter. So 3 times 2 to the fifth is 3 times 32 over 5 plus tangent of pi over 3 over pi over 6 minus the quantity 3/5 plus tangent of pi over 6 over pi over 6. Okay, so we get 3 times 32 over 5. I don't think that reduces at all. So I think this is just going to be 96 over 5. Yeah, there's no factors of 5 in there. Fine. Tangent of pi over 3, remember, is just root 3. That's going to be over pi over 6. We'll deal with that in a second. We'll sort of flip that up. Minus 3/5 minus tangent of pi over 6 is 1 over root 3. 1 over root 3 pi over 6. Okay, so coming over here, 96 minus 3 gives me 93 over 5. And then let's deal with this. Flip this up so I get 6 root 3 over pi. And then over here, it looks like I get 6 over pi times root 3. And there's no, without getting the common denominator and dealing with that, I would consider this simplified. Okay. Part B, what do we have? Integral from -3 to -1 of e to the negative x minus 4 over x dx. Okay, so again, I'll keep it all together and do it as one. But if you wanted to split it, not a problem. Okay, so I have e to the -1 times x. That means I get as my antiderivative e to the minus x divided by, crap, leave a little bit more room there. E to the minus x divided by -1. That'll just end up being negative e to the minus x, but I figure I might as well show it. Minus 4 times the ln of the absolute value of x. And this problem is designed to show you how important that is, because the interval we're evaluating on is a negative interval. So we have to make sure we're only taking positive numbers inside of an ln, because ln is not defined for negative numbers, or 0 for that matter. Okay, so we have now negative e to the negative x. I plug in -1 first, right? I go top to bottom. So I get negative e to the -1, which is just to the 1, minus 4 ln of 1, because I take I take the positive part of -1. Okay, and then I get minus whatever I get when I plug in -3. So I get negative e to the third minus 4 ln of 3. Okay, so it looks like I get, remember ln of 1 is 0. So I get a negative e, I get a plus e cubed, and a plus 4 ln of 3. So let's say e cubed minus e plus 4 ln of 3. And if you want to get cute, I suppose you could do e to the third minus e plus ln of 81. Same thing. Either one is fine. I would never require you to do that, but if that's what you got, that is correct. Okay, part C. Integral from 0 to 1 of 100 e to the pi times cosine of pi x plus 45 over x to the negative 46 plus 100 x to the 99th dx. Okay, keeping it all together and working through it. Not much different here in terms of computations, just a cosine really seems like the only difference. Okay, so I have 100 e to the pi. Remember, this is just a constant because it has no x's in it. So if I were to split this up and I were to deal with these as their own terms, this 100 e to the pi can come outside the integral because it's just a constant. So don't let this affect you at all, even if you see letters like e and pi, things like this. If it's not an x, it's just a constant. So it has no bearing really on the integral. It just sort of comes along for the ride. So the integral of cosine is sine, but I have to remember to divide by the inside part. So I get 100 e to the pi sine of pi of x, or pi times x, divided by pi, right? I divide by pi because of this coefficient in here. Remember, pi is also a constant, and here it's the coefficient of x. Okay, so here, really what I should be doing is rewriting this. So what I'm going to do is I will do it all separately for this one, just because I should have rewritten it to begin with, but it doesn't really matter. To see this more clearly, let's write this way. Right, now this is something we can sort of handle a little bit better. Negative exponents I don't really care for too much. But in this case, it actually turns out that, well, in the integration case, it turns out that negative exponents will help. The more the point is that you want everything to be on the same level. Fractions are bad. So whatever, even if this was a positive 46 down here, it's still a good idea to bring it up and make this a negative 46, just because it's easier to see the reverse power rule. Similar to derivatives, right? It's easier to take a derivative when everything is sort of on one level and there's not a fraction there. And then, okay, I can handle this without having to rewrite anything. Add a power, divide it, the 100 goes away. So I just get x to the 100 on the interval 0 to 1. Okay, so let's evaluate this. This part will sort of be lagging behind, but that's not a problem. All right, if I plug 1 into this, I get 100 e to the pi sine of pi, terrible e, over pi minus 100 e to the pi sine of 0 over pi, and I'll put that in brackets. Know that this is sort of just corresponding to this part, plus, and then I get here 45x to the 47th over 47, 0 to 1, plus, and this is pretty easy, I just get 1 minus 0. 1 to the 100th is still 1, 0 to the 100th is still 0. Okay, sine of pi is 0, so this whole thing goes to 0. Sine of 0 is 0, so this whole thing goes to 0, so this whole term is just 0. 0 minus 0. And here I get 45 over 47 times 1 minus 45 over 47 times 0, so that's just 45 over 47 plus 1. So I get, what, 47, 45 plus 47 over 47. So it looks like I get, what, 92 over 47. Okay. Now moving on to the indefinite integrals, number 2. No simplification required for these because there's really no evaluation of anything. All right, so I get 10x to the 5th plus 16x to the 4th plus 6x to the 3rd plus 20x plus 1 dx. Again, I'll do it all as one. So I get 10x to the 6th divided by 6, because I just raised the power, divide by that new power. Same thing here, 16x to the 5th over 5 plus 6x to the 4th over 4 plus 20x squared over 2 plus x. And then, of course, plus c, because we're doing indefinite integrals here. And then I guess a little bit of simplification is in order here. 5x to the 6th over 3 plus nothing can happen here. That's fine how it is. That one can reduce to this. Great. And this one, 2 can come out of each, and I just get 10x squared. Of course, x stays the same, and c comes along. That's just about the simplest example we can give. It's just iterations of the reverse power rule. Okay, part B. Integral of x to the 5th minus x to the 3rd plus 4x, all divided by x to the 6th. And then I get a plus 8 over 5x to the 1/5 dx. Okay, now this one requires a bit of a trick, and I think this is a trick that we showed earlier in the course. If you have a function like this, where even to take a derivative of this thing is a pain, so you have to imagine that taking the integral of it is really a pain. But there's a nice thing we can do here. So here's the idea. Remember how fractions work, right? I can write a fraction like this if there's a common denominator, or I can write it as a separated out grouping of things. Like this. Oh, crap. I don't want to put parentheses yet. I want to do this. And then similar to what I did last time, I want to write everything so that x is sort of on the top. So I'm just going to rewrite this as 8/5 times x to the negative 1/5, right? Just bringing the x up to sort of the top part. This is linked by multiplication here, right? But the main trick about this problem is to notice that you can split this up in this sort of a way. And why do I do that? Well, hopefully it's obvious. Now I can reduce my powers, right? Now I can sort of divide. Essentially, that's what I'm doing, is dividing. So I have x to the 5th over x to the 6th. Of course, that reduces to 1 over x, or x to the negative 1, whatever. X to the 3rd over x to the 6th is 1 over x to the 3rd, because I'm just subtracting. 4 over x to the 5th, because you get 1 minus 5, so the 5 stays down on the bottom. And then I still have 8/5 times x to the negative 1/5. And now the last thing I want to do is rewrite these so that all my powers are, well, so that everything is sort of up at the top level. I want to make sure that it's written this way and without x's in the denominator. The one that I will keep though is this guy because I do know what his integral is, so I'll keep him. But everything else I'll change. So let's say 1 over x minus x to the negative third plus 4x to the negative fifth plus 8/5 times x to the negative 1/5 dx. Okay. Now we can finally do this. We'll do it one piece at a time. Integral of 1 over x is ln of absolute value of x. And then here I add a power to this. Now remember, negative 3 plus 1 is negative 2. Don't make the mistake of thinking this is negative 4, right? So just be careful when you're dealing with negative exponents. It's easy to make a mistake there. All right, so I have minus x to the negative 2 divided by negative 2. So this negative and that negative will cancel, but I'll show that in the next step. And then I get 4x to the negative fourth, right, by a similar thing, and then divide by negative 4. Then I get a plus 8/5 times x to the now 4/5, and that whole thing is going to now be divided by 4/5 plus c. Okay, so let's do a little bit of simplification here, whatever we can do. For shorthand, you don't need the parentheses. You can just put the bars like that. Okay, so let's rewrite this. The negative is going to go away. I'm going to have a 2 on the bottom, and I want to get rid of my negative exponent just to make it look a little cleaner. So let's bring that down to the bottom. So I get a plus 1 over 2x squared. This turns into a minus. The 4's cancel, and I bring my x to the negative fourth down to the bottom. I get a 1 over x to the fourth. Now to see this simplify, let's do it over here. I got 8/5 x to the 4/5 over 4/5. So remember, this is the same thing as, let's say I write the x to the 4/5 up here with the 8, doesn't matter, times now 5/4, right? Remember how dividing fractions goes. I take the top fraction, which I've written here, and I multiply by the reciprocal of the bottom fraction. So the 5's cancel, and this reduces down to a 2. So I get 2x to the 4/5. So that's what I'll get here, 2x to the 4/5 plus c. And that's my answer for that one. Okay, that's part B. Let's do part C now. Integral of 2 over x plus 20 cosine 5x minus 20 sine 4x dx. All right, this one's pretty straightforward. Nothing really to think about here. This is just 2 times ln of absolute value of x. 2 times 1 over x gives me, of course, 2 times the integral of 1 over x, plus 20 sine of 5x divided by 5. And then I get, well, the integral of sine is negative cosine, but there's already a negative here, so I should get a plus 20 cosine 4x over 4 plus c. So I still have 2 ln absolute value of x plus 4 sine 5x plus 5 cosine 4x plus c. And that'll do it for that one. Okay, and finally number 3. The hint basically gives this one away. And since the video about U-sub was uploaded, probably, before you guys finished this homework, before you started it in a lot of cases, you were able to do this pretty easily. So this is pretty clearly written in the form g prime of x times f prime of g of x. This is already in that form where f of x is, well, the antiderivative of cosine, so that's just sine of x, and g of x is x squared, right? So the antiderivative of this is just f of g of x. So the answer to this is just sine of x squared. And of course, just don't forget the plus c. And this is pretty clear. If you take a derivative of this, let's just check. It's always nice to check when you're doing a u sub problem. So derivative with respect to x of sine of x squared plus c. Okay, so derivative of sine of x squared, that's a chain rule. I get cosine of x squared. Then I have to remember to multiply by the derivative of the inside, get the 2x, and the derivative of a constant is just 0. So I get this, or I could rewrite it as this. And this is exactly what I had in my integrand here. Okay, if there are any questions, feel free to email me. And otherwise, good luck on your final. I'll see you on Thursday.